Okay, ladies and gentlemen, good afternoon. Welcome to today's brief video on converting from moles to particles. Already we've done moles to mass and mass to moles. Now we need to be able to convert back and forth between moles and particles. Now, recall Avogadro's number as we read through here. Avogadro's number means that there are exactly 6.022 times 10 to the 23rd particles or things in a mole equal 1 mole. Now, as we recall from lecture, the mole is just like a chemist's dozen. So as a dozen is to a store owner, the mole, which is 6.022 times 10 to the 23rd, is to a chemist. It's just simply a quantity, so it can be used to describe almost anything, but usually chemists tend to describe either molecules or atoms. So down here below, we're going to recall what goes where in our unit conversion tool. Again, remember, in the top left-hand corner, we write our given quantity, and make sure that you write the unit. If you don't write the unit, then we'll get confused when we go to the right. This right here is our conversion ratio. In this case, our ratio will be 6.022 per 1 mole. So that could either be 1 mole down here or 1 mole up here. That could either be 6.022 times 10 to the 23rd down here or 6.022 times 10 to the 23rd up there. Just make sure that the units match. So we need to make sure that we match units with our given amount. And then up in the top right-hand corner, we're going to write our looking for units. Make sure that you end with what you're looking for, so that then our given units will cancel and we'll be left with just what we're looking for. All right, so let's put this to practice. Our first example problem is that Mars is 5.6 times 10 to the 7th kilometers from Earth. If astronomers were as cool as chemists, they would use moles as a quantity to represent the amount of kilometers between locations. So let's help them out by calculating the amount of moles of kilometers that are between Earth and Mars. So in order to do that, we start with our given quantity, which is 5.6 times 10 to the 7th kilometers. Now, we are looking for the amount of moles of kilometers between Earth and Mars. So we're trying to convert from kilometers to moles of kilometers. So given quantity and unit. Our given quantity is 5.6 times 10 to the 7th, and our unit is kilometers. Now we need to make sure that we match our units with our given quantity. So our ratio, again, we're going from kilometers to moles, so going to moles of anything, we need to use 6.022 times 10 to the 23rd as our conversion ratio for every 1 mole. So we need to match 6.022 because there are 6.022 times 10 to the 23rd kilometers in 1 mole of kilometers. All right, now when we go into our calculator, again, recall that we need to use our E button to represent this. So we're going to type in up here 5.6 second comma to the 7. We're going to multiply across the row times 1, divide that by 6.022 second comma to the 23rd. And that gives us this quantity right here, which is much smaller than 1, which makes sense to me because it is not quite 6.022 times 10 to the 23rd kilometers to Mars. So our answer should be 9.2. Actually, according to sig figs, it should be 9.3 times 10 to the negative 17th moles of kilometers to Mars. And that's all. So let's do one more sample problem, or another sample problem. We say that Proxima Centauri is the closest star to our Sun. This is 4.24 light years, or 9.46 times 10 to the 12th kilometers from the Sun. How many moles of miles is our closest stellar neighbor? So again, we're given 9. This should read moles of kilometers. Whoops. 9.46 times 10 to the 12 kilometers. How many moles of kilometers is our closest stellar neighbor? So we put our given up here, 9.46 times 10 to the 12. Our given unit. We need to match our unit, which is 6.02. So again, our conversion ratio is 6.022 times 10 to the 23rd for 1 mole. So this is kilometers per 1 mole. So again, we're just going to plug into our calculator 9.46 second comma to the 12th. Oops. Divide that by 6.022 second comma to the 23rd. Our final answer should be 1.5 or 1.57 times 10 to the negative 11th moles. All right, now for our last sample problem, which reads, now that we have helped our stellar friends to understand the utility of the mole concept, it is catching on. Hooray! The nearest Earth-sized planet in the habitable zone of another star is Kepler 186f, and this was as of July 23rd, 2015. So this is 7.97 times 10 to the negative 9th moles of kilometers from Earth. How many kilometers away is this? So now we're given moles and we're asked to convert back to kilometers. So we write our given quantity, which is 7.97 times 10 to the negative 9th moles. Now we need to match our units with our given. So instead of putting kilometers down here, we have to use our 1 mole from our ratio to 6.022 times 10 to the 23rd kilometers. So moles will cancel, we're left with kilometers. So we type this into our calculator and we get 7.97 second comma negative 9. Now recall for the negative we have to use the negative button just below the 3, not the minus button below the times, so negative 9. And then we multiply that by 6.022 second comma 23rd, and that should give us 4.79 times 10 to the 15th, 4.80 times 10 to the 15th kilometers from Earth. Now, that is quite a distance, and if you think about it, even if they're moving at the speed of light, that is, which is the fastest quantity, or the fastest speed in the universe, then it would take quite a few years to get to Earth. So it's kind of interesting to think that even if there was life in this habitable planet, that somebody would come to do a teenage prank, spend all that time in a spaceship to do a teenage prank such as drawing circles and crops. Leaves quite a wonderful question. All right, anyways, back to the mole concept. Hopefully this is helpful. Remember, when we're converting from moles to particles, we always use the ratio of 6.022 times 10 to the 23rd for 1 mole. Have a wonderful afternoon, and hope that we all come into the test ready